Hi, this is saying today I would like to share the proof of the mean of a binomial distribution equal to NP. Given that the random variable x follow a binomial distribution with parameters n and p and the density function, okay, so we know that the expected number, or what we call the mean, is the total of all the possible number of x times the density function, or what we call weighted average of all possible numbers. So we have, okay, since when x equal to 0, anything times 0 is 0. So we can omit it, we just remove, so we start from 1. So x times the density function we have, and x, okay, and choose x, p power x, and q power m minus x. Okay, we do some simplification here. So n times n choose x is actually x times n factorial over x factorial times m minus x factorial. Okay, in order to remove this x, I will make use of the properties of the factorial. Okay, so if let's say I have 4 factorial, basically is 4 times 3 times 2 times 1, which is 4 times 3 factorial. So I will have x factorial here. So x times x minus 1 factorial. Okay, x factorial. So x times x minus 1 factorial. Then times m minus x factorial. So for the numerator, in order to have the same pattern, so I will take minus 1 as well. If let's say I take m minus 1 factorial, I have to times n. So x and x cancel each other. Okay, then for this part, okay, obviously, okay, we have m minus 1 x minus 1, okay, times m. So this is equivalent to the summation from x equal to 1 to n x, okay, the factor, the binomial factor. Now we have m minus 1 x minus 1. Okay, in order to have the same pattern x minus 1, okay, for the power of p, then I will have p times p x minus 1, okay, times, so we have the power 1 plus x minus 1, so we will get back x, exactly the same. Okay, then same for the power of q, so we take m minus 1 minus x minus 1. So minus 1 minus minus plus. So plus 1 minus 1 plus 1, we get 0. So we get back m minus x. Okay, we take out the one that not involved in the calculation of x. Okay, since n and p are not involved in the calculation of x, means that they are constant. So we take out n and p. So we have summation x equal to 1 to m minus 1 x minus 1, okay, p x minus 1, then we have q, okay, n minus 1 minus x minus 1. Okay, we do some simplification here. So we let k be m minus 1 and j be x minus 1. So we have total for j. Okay, when x equal to 1, 1 minus 1 is 0. J equal to 0. Okay, then we sum to, okay, k equal to m minus 1. So if let's say m minus 1 is equal to k, so it means that the maximum number that a binomial can weight is k. So we put k here. Okay, although n is equal to k plus 1, but k plus 1 is undefined. So we put k here. Then x minus 1 is j. Okay, p x minus 1 j, q n minus 1 is k, minus x minus 1 is j. Okay, as we can see, this is actually the probability density function of a binomial distribution. And we know that the total probability density function of a distribution is equal to 1. So meaning to say n times p times the whole thing here, which is equal to 1, we obtain np. Then we already proved it. Okay, thanks for watching. Hope you like this. See you.